I picked another, I figured we can work on another Tidy Tuesday data set today. And I have a feeling some of you might know more about this data set than I do. Let's admit these people too. Okay. So this week's data set is on Beyonce and Taylor Swift lyrics. Although the data is not just lyrics, we actually have 4 data sets. One of them, or 2 of them, are lyrics. So we could choose to do some text analysis, which we'll cover a bit more formally at the end of the class, but I'm happy to teach you a couple functions to kind of go from lyrics to words, and then we could do some simple analysis on the words without fitting any sort of models, but just making visualizations is basically the goal for today. We have another data set on sales and another one on charts. So I'm going to put the link here in the chat. And so this is where you can read about the data, and you should have this link open because I'll be asking you, what should we look for? What should we try to visualize? And the names of the variables are going to be helpful for doing that. And so in the lyrics, we basically have line by line lyrics. So however the song is written, kind of like a poem, I suppose, we have the lines. And then we also know the name of the song. And it doesn't seem like we know the album. So that's something to keep in mind. And then we have sales for the country for sales. So the various country sales, maybe we'll take a look. And then charts. So I guess how well did the song do in the charts? Okay. If you would like to follow along, you can go to RStudio Cloud, and there's a code along project that I put here, and I pre-installed a couple packages in it as well that's going to be useful for us. So I'm going to go ahead and start that. I know that we have some people who are new to the course. I don't know if those have joined the call today. If you are new to course and you're like, I've never logged on to RStudio Cloud, what I would recommend is watch what's going on as opposed to try to catch up with going through all the signing up process right now, because you're just going to fall behind. And then you can kind of go through the course videos, which walks you through everything you need to do to get to the point that we're in. There's a question in the chat. Does anybody want to answer that? I'm guessing some of you know the answer. Yep. Trust me, if I was to grade homework 0, it would be more of a pain for me than you guys, because some of you are just, adding on to the class. It would be wholly unfair if we graded it. And if I decided I was going to do that level of record keeping, we would never get anything else done. Okay, so here is my RStudio Cloud window. What I will do is, how is the font size? Are people able to read this? Shall we try to make things maybe a little bit better? All good. Okay. You guys have better eyes than me. All right, we'll keep this a little bit bigger, and let's try dark theme this time. Let's give it a try. Project options. Is this where it is? No, maybe under global options. There we go. We have appearance. Let's make this a little bit bigger. And we can do dark, but then we have to go with my favorite dark theme. So we'll use this one. Okay. All right. Okay. So as I said, we're gonna, as usual, use the tidyverse package. The skimmer package is what we've used in the past for kind of taking a peek at the data as well. And then you can then if we do the text analysis as well, we're going to use a package called tidy text, but I'm going to set that aside for now. There's a question about making dark theme default. Yes, it is if you have things locally installed, but currently no on RStudio Cloud, because that sort of information doesn't get carried over from one project to another. But I can assure you that it has been asked, and I think it's on the engineering team's like to-do list, because people who like the dark theme are kind of obsessed with it. They don't just like it. Okay, so here we go. I'm going to load these data sets, and as usual, because I have data that is in CSV format, which is comma separated values, I'm basically loading them in using the function called read CSV. So that's read underscore CSV. So far, we've talked about only two ways of getting data into R. One was it's already in a package, so we load the package and we get the data with it. And the other one is it's a CSV file, and we use that to get our data. These are not the only types of data you might have, but these are the ones that we're focusing on for now until we get to the specific unit on importing data, and then we'll say more. So let's do a little bit of a data overview. So I'm going to go ahead and insert an R chunk, and let's start with the sales data. I want to take a look to see what sort of data we have here. I'm going to make this a little bit wider so everything prints on one line. I get a little bit annoyed when that's not the case. Here we go. So we have a bunch of variables that are characters, which makes sense, like things like artist and title and whatever. And we also have a variable called sales, which is the sales amount. And we have this like inline histogram of this thing, which shows me that things are very right skewed. So another thing I like to do whenever I take a look at a data set is this skim output is useful. Maybe we should also take note of the number of rows. So there are 48 rows and the number of columns. But one thing I'm having difficulty with looking at this is what does each row represent? It's a little bit hard for me to understand what each row represents. So I'm also going to say, okay, I want to pull up this data set as basically a data.
现在车都可以直接接电话，好吗？
Could you mute?
只要不给我打微信电话。
Okay, there we go. Okay. Unfortunately, I'm sure this will happen multiple times. It's just like the way our lives are. Okay, so here in the sales data set, we have each row is a album / country, I suppose. Does anybody know if these are albums? I think it is. This 1989 was a Taylor Swift album, I think I remember. And then we also have Beyonce albums as well. So let me go ahead and say, let's make the text a little bit bigger. And then let me answer a couple questions from the, there was something about naming our chunks. So I will go ahead and talk about that. So you'll see that whenever I give you templates, our chunks are named. Like for example, I have load packages or load data. And here, when you create a new R chunk, it's not by default named because it's meant to be something informative. It actually doesn't matter what you call it, okay? It is meant to be informative. There is one thing that makes it into that you will bite you, I bet. And that is if you have, let's say I was to say, let's skim the sales and the charts. And if I was to knit this document, I'm going to get an error. And the reason why I'm going to get an error is this code label that I have is repeated. And in fact, it says duplicate chunk label. So if you're going to give your chunks labels, which I'll be asking you to do, you should actually give them short but informative labels, something like this. And as long as they are unique, the document will knit. In order to add an R chunk, you literally could actually type this out. However, this backtick appears in different places depending on what sort of a language your keyboard is, like what country actually you bought your keyboard in matters. Or you can go to insert and then click on R to get an R chunk. This other language names are here because you could run code in other languages as well, but we're not going to do that in this class. Okay, so we know that we have album sales in various countries. So the number of albums sold, and we also know the release date. And then we also can look at the charts data set. We can both get a skim output of it. And I also, as I said, want to take a look at what this data set looks like. So here, an album called, all right, Taylor Swift is released in October 2006, and then we know the chart position in various countries. Okay, so that's sort of the type of information we have. And then if I was to look at the lyrics, you'll see basically that for a given song, we have the IDs as opposed to the names of the songs, it seems like. So we should be able to, oh no, we do have them. The song names, we basically have the lyrics for the songs down the line. And we have a data frame for Beyonce and one for Taylor Swift. So initially what I'd like to do is focus on sales and charts, and let's make a type of plot that we've already learned how to make. So I'll ask you all, what type of thing would you like to look at in terms of the sale, either the sales or the chart position of these songs? We could do something comparative, or we could just look at one of the artists. If you want to get some ideas in the chat, we can give it a try. Chart position versus continent. So for a given song, how did they do in various continents? So if we were to look at continents, we would need to first figure out which continent each country is in. I think what I'm going to do is let's look at it per country as opposed to per continent for now, so we don't have to bring in one other data set. That is the sort of thing we're going to learn about in a couple weeks, but I'll push that off until then. So let's go ahead and take a look at for various songs, how they did in the charts in different countries. What would you like to see on the x-axis versus on the y-axis? I'm trying to kind of sketch out what might this look like if we want to compare how songs did in various countries. Should we find average chart position per country, maybe? We could try that. So we could say, so I'll put this under charts. So I'll say chart position and countries. So we could start with the charts data set. And then since we want to do things at the country level, we might want to group by country. Is the variable called country? No, I guess it's called chart. So let's call it chart. And then we could say, give me the average. So this is average chart position is mean of the chart position. Oh, lots of NAs. Why might I get an NA when I'm calling the mean function? Does anybody remember why this might happen? I might have some NAs in my data to begin with. So let's try this. That also didn't work. What's the issue? Group by chart. We also have different artists here, right? We probably want to separate those out. We'll do a box plot next. In fact, maybe we should do the box plot first. Okay, so we have, for each one of them, we can find out their average chart position in the various countries, although we are not yet getting to that information. Let's try to see what might be happening. I wonder if these data are not coded as, do you guys see how we have these like little dashes? So chances are this data set, the chart position variable is not encoded as numeric, as like numeric data, because somebody decided it was a good idea to put dashes instead of just leaving the cell blank. It is categorical, exactly. So then it doesn't find the mean for me. So what we can do is we can say, well, just convert these to numeric variables. And so this is getting into various data types, which is something we'll talk about more. But now those ones with the dashes just like went away, and R is telling me I just put some NAs in there because I didn't know what to do. That's what this warning is saying. And then we actually have the various chart positions. So now that we have this, what we could do is we could make a plot where on the x-axis, maybe we have the chart, which country it's coming from. And on the y-axis, we have the average chart position. And we could create bars that are basically the heights of those should be equal to these numbers. So for that, I would use a geom called geom_col, which is similar to geom_bar that you've seen in the videos. And what we're doing here is that we're saying just grab the y-axis value from whatever average chart position is for that row, as opposed to count how many times something is occurring. So let's go ahead and run this and see what we get. We get some heights per country, but so a good question from Eleanor, do we not need to tell ggplot what data set to use? That's a really good question. I didn't have something like data equals something, right? Which is how you're used to seeing ggplots. But what I've done instead is I said, well, calculate these summary statistics for me and then pipe it into the ggplot function. So this is basically like saying data is equal to whatever we calculated up until this point. And let's also say we want to facet by the artist, right? The variable is called artist. And so here we have for Beyonce and for Taylor Swift, their chart positions in various countries. And really good point, Connor. Here, bigger is not better. We actually want for a chart position things to be lower. So we can actually see that, let's see, where is Beyonce is doing the best in the US and then in Ireland, it seems like. And then Taylor Swift is also doing best in the US and then Canada, for example. Yeah, maybe he was. I don't think Kanye is right about a lot of things, but maybe he was about this. Okay. So one other question was, how did we get rid of those dashes? So the way we got rid of those dashes is where I said, turn the chart position variable into numeric data. Okay. And what R does when you do that is it takes a look at the data and it says, can I turn it into a numeric? If the number 5 is given to me as a character, do I know how to turn it into a numeric variable? And the answer is yes. But when you have dashes, it basically converts them to NAs. So I'm seeing a comment saying this is intimidating. I think it is intimidating because based on the trajectory of things you guys were asking, we actually ended up doing things that we hadn't seen before in the first few lines of the code, right? This summarization is something we've barely seen, and we certainly haven't done any sort of numeric like conversion of data types. And this is kind of to make a point to say that you are going to learn all of this stuff, but we are not going to be able to learn all of that in just 1 week of material in the course. So how about that other idea we had, which was about making box plots? Can we actually make various box plots for these countries and artists? Because that is something that we should be able to do knowing what we know so far. So let's go ahead and create a new R chunk and say that we're going to start with the charts variable. Okay, a charts data frame, I'm sorry. And then, or actually, let's do it this way. Let's say we're going to create a ggplot where the data frame we're using is charts, right? And I said in one of the videos that you might often see this argument name omitted. So you might just start with this. And what do we want to put on the x-axis? Shall we put maybe shall we do this same visualization, but more in a box plot format, where in the x-axis, we would have the country names. And can somebody remind me which variable in this chart's data frame the country names were? Chart, exactly. So let's put chart on the x-axis. And then maybe let's make just a geom box plot of this and see what happens. So for various countries, oh no, what we want to actually have on the y-axis is the chart position. Called chart position, yeah. Here we go. This looks all over the place. What's happening? Does anyone know why this y-axis does not look like numeric data? It is both artists, so that's confusing matter. So that's definitely something we're going to need to address. And the other one is we still didn't convert things to numeric. So I'm going to go ahead and convert this chart position to numeric. And now this is looking more like what we want to see, right? But these chart positions are for both artists together. So what should we do? We want to separate it out for Beyonce and Taylor Swift. So we have two ways of doing that. We could do a facet ref where we put them next to each other. So let's go ahead and try that. So now we can see the two artists kind of separately in various plots. What I find a little bit hard about this is that it's really hard to compare within a given country how the two artists have done, right? You kind of have to look around to see, okay, France was here for Beyonce and it's over there for Taylor Swift. So maybe instead of splitting them into two, how about we say we want to color by artists in the original plot. And now we can actually see them next to each other, all right? Another option is to maybe stack them vertically. So how about we did that? We put the various countries on the y-axis and the chart position on the x-axis. So all I've changed is the mapping here. And maybe this is a little bit easier to read. So what are some insights that we might gain from this? If I pop this out, is this still visible? Yeah, okay, great. So let's take a look at this a little bit bigger. What might you say about, so what was each observation in this data set? It was an album, right? France does not like Beyonce or Taylor Swift. That's something we're definitely seeing. The chart numbers are low, basically. What else do we see? What does the width of the box plot, so how big the box is, what does that tell me? The IQR, which is the inner quartile range, which basically tells you how spread out are these data. So in France, not only on the medians, which are the thick lines in the box plot, are higher numbers, meaning that the artist did not do as well there. Also, the boxes are really big, meaning among the various albums for both of these artists, the variability was high in terms of how they did in the charts. Other insights, English-speaking nations love them the most. So Canada, Australia, US, that maybe kind of makes sense that they sing in English. So that does make sense. So I like that insight about the English-speaking nations like them, which is correct. But I would also warn against making a sweeping statement without like a modifier to it. I think that statement is correct, but that's based on the data that we have, right? We don't have data from all the English speaking countries and all the non-English speaking countries. So according to the data for which we have chart information for, the English speaking countries seem to like these artists a lot better than others. And you can see that this sort of insight is something that's like that you develop iteratively. First, you want to actually state what you see, and then you want to step back and think, might I have overstepped? Did I maybe say more than I should be able to say with a data set like this? Sweden seems to like Beyonce, but not like Taylor Swift. Let's see, where's Sweden? Yeah, I don't know why. I guess. So let's think about this. I wonder if, you know, one of the things that comes to mind also is, did we have the same number of observations for each of the countries as well? So that's another thing we might want to look at. And that's the sort of thing that, you know, maybe some albums get released in certain countries and not others, although probably not in this day and age with like iTunes and stuff. Probably everything does get released, but they may not be as well promoted in different countries. So that might be another thing to consider. Anything else we want to look at? Right, we also have these crazy outliers. That's right. I'm kind of actually interested, which Taylor Swift album did so bad in the UK? How might I get to this? So let's try to think about what are some things. I'm going to use a function called filter to try to figure this out. Although, let's try to figure this out in two ways. I'm going to do it the easy way, and then I'm going to do it the slightly more complicated way. The easy way is, right, the easy way is because there's only one that's so big and this is not a huge data set, I can actually look at this data viewer and interactively like just sort it by clicking on the variable that I want to sort by. Look at this, 81. This was the Taylor Swift album. I think that people maybe didn't know about Taylor Swift over here back in 2000. Maybe that's what was happening. I think so, yeah. So maybe that's why it didn't do very well. Now, another way of figuring out that outlier would be to say, start with the charts data set and then filter it for where chart position is, we could say greater than 80. So that would be one way to, oh, we have to do as numeric. I keep forgetting that this data is a little jacked up. So we have to do as numeric. So filter it for those that are greater than 80. And it's really hard to read this output. So another function we mentioned in the office hours yesterday was this function. So we can just like let it print out for us. So this was the name of the album, the Taylor Swift. Okay. Does anyone know how to get the view of your plots or your output in the same window? Do you mean getting it over here as opposed to, I'm not sure what you mean by the question, Emma, but if you want to clarify, I'd be happy to. Right, so Nabil, there's a really good question. Can't we define a variable that sets chart position as numeric and then just call it that from now on? We absolutely can. So instead of having to remind ourselves to constantly do this, we could have saved it as such and then used it as the numeric variable along the way. So what the pull function does is it like takes a look at your data frame and then just pulls out the information and prints the information out as like either a character string or a numeric. Okay, what else do we want to look at? We can keep looking at the charts, or we can keep looking at sales, or we can keep looking at something else. Let's try to think about something where we can make a visualization, since that's the theme for this week. And let's try to make a visualization that kind of the sorts of things we know how to make. Shall we do something similar for sales versus chart position? That's a good idea. The albums that were equally loved. I'm trying to think which one of these is sales by label, release time, and chart position. So what I'm going to try to do is I'm seeing some really good suggestions in the chat, but some of them are requiring that we use data from 2 separate data frames and join it into one before we can use it. And that sort of thing I'm going to hold off on doing because we're going to learn about those next week. And I want you to learn about doing data joins properly first before we go ahead and do that. But something like sales and sales, we can look at the different sales per album for artist, or sales and release time is something we can definitely do. So how about let's start with that, sales and release time. So I'm going to go back into the sales bit here and say that we want to look at, so we will make a plot using the sales data set, right? And on the x-axis or on the y-axis, maybe we want to have the sales amount. I'll try to hook up my iPad next time we do this so I can first kind of draw it out for you, like a diagram it, and then we can do the coding. I don't have it ready to go now. So let's say on the y-axis, we have the sales. What should we put on the x-axis? Which of these variables? You can do a glimpse of sales here just to remind you what the variables were. Maybe release year. How about that? And then we can color it by the various artists, for example. So, and on the x-axis, I can do, so there is a function called year that should actually take out the year from any string, like any text string that looks like date. So let's go ahead and load this package. Called Lubridate, and say, give me the year of the released date. And then maybe do a geom point to start with. Does this get us what we want? Nope. Every single thing we're trying requires one additional thing that we need to do. Let's take a look to see what we have here. So these are character strings, and we want to actually just get the years out of them. How might we go about doing that? It's usually able to recognize any character string that looks like date, but this is month, date, and then year. This work? Here we go. Yeah. So the released variable looks something like this. It comes in the order of month, date, and year. So what I said is turn it into a date that's of the form month, date, year, and then just extract out the year for me. Okay. So on the x-axis, I have years, and on the y-axis, I have the sales. But these are for both of the artists. So I think we might want to also color by artist, just so we know who is who. Okay. So these are the various sales of the artists. And let's take a look at this. Do we have different countries here as well? Yes. And so in a given year, it's not that Taylor Swift had 5 albums out. It is more that these happened in different countries. So we probably want to separate these out by country. I loaded the new package by just doing library and then the name of the package. So let's maybe do facet wrap and then country. Okay. So here is what's going on in the various countries. What I would like to do is, in some of the countries, I have so little data that it kind of just seems silly to look at them all together. Which countries seems a bit more reasonable to look at based on how many data points we have? UK and US, right? That seems like maybe those are the things we want to do. So how about we go back and say, let's just start with the sales data frame and only filter for where country is in UK or US. So this is a precursor to the types of things we're going to learn next week, where we can filter not by based on it's greater than or less than, but we can do more complicated logical statements saying if the country's in either UK or US, give that to me, and then make the ggplot only for these countries. So I'm going to get rid of the data here because I've now put this in a pipeline. So let's go back and see what I'm doing here. Start with the sales data frame, filter for just UK or US, and then just plot it. And then when I just plot it, then I actually get to omit the data argument here because it's coming from the previous line in the pipeline. So let's go ahead and do this. So now we're just looking at UK and US. So Purvi asked, is it possible that did both albums get released in, oh, the same albums get released in both of the countries? I don't know. It's possible they did or not. So the C does not, it's not for country, it's for creating a vector in R. So another way I could have written this, maybe that would be a little bit more clear, at least at this stage in the course, was to say either country is equal to UK or, and this vertical bar is what we use to say or in R, or country is equal to US. Okay, so the way I would read this is either country is equal to, so this is like a logical statement or a question, or country is equal to US. Okay. What does this tell me in general? Or what are some things about this plot that's like hard to read? Is there anything that's bugging anyone about this plot? Anything we could fix up a little bit more to make it a bit better? The sales scale is annoying, right? It's like hard to tell what those numbers are. Can we put the subplots in rows instead of columns? Sure, so the years would be on top of each other. We can definitely do that. So we can say, no, n row is equal to 2, so that it would put them on top of each other. Move the grid lines, sure. Actually, I don't like this gray background we get so much in R. There's a theme called minimal that I like a little bit better. Personally for my use. So we can do that. We can change that. Let's change the sales scale as well. So, okay, so that's another question. Is there a way we click on the plot and find the exact value as in the coordinates? Not the way we are building the plots. That would require some interactivity. And so we're going to say more about like building interactive visualizations in R a little bit later, but it won't be a main focus of the course. So as of now, there isn't a great way to do that with what we've learned. And I hesitate to take the step to talk about that because it's not actually something we will end up encountering in the class. When you guys ask questions where I know we're going to talk about it anyway, I don't mind throwing it at you because then you'll see it again. But when it's something outside the scope, I might try to hesitate to do that. So let's change the sales scale. So there's another package called scales that we can use. So the name of it is scales. So actually, let me take better notes and add it up here. What was another package we used so far? Lubridate. Not luminate, but lubridate. And so this is scale on the y-axis, continuous, because it's a continuous variable. And what we say is we want label dollar, maybe. There we go. So it basically turns things into dollar amount. So we can see a little bit better what these data are. Anything else you want to change here? Right. So that's correct, Connor, that the populations are different. So the sales amounts may be different. Well, actually, there are two. I think that sales amounts are adjusted to US dollars. So that's okay. Yeah, we could do some sort of proportion by country, but then we would need to, as David said, get that information about the country populations. The x-axis title, yeah, that's super terrible, the x-axis title. So we know how to do this. This is something we've seen over and over in the videos. We use the labs function. So for the x-axis, I get to give a character string. What character string should we use? Year released, sure. And then for the y-axis, we can say it's sales in USD, maybe. And then for the color, make it like capital letter A for artist. So it looks something like this. 6 million doesn't sound like a lot. I think it's the number of sold albums. That's a good point. So let's take a look at what the data is about. No, it says sales in dollars. So it does seem like it is actually dollars. And we did use the sales variable, right? Yeah, sales. Yeah, but that's a really good like thing to catch on to. If something doesn't look right, the first place you want to go is actually the data dictionary to see, is that right? So is there anything else anybody wants to change, or are we happy with this? All right. So we have a few minutes, like 5 or so minutes left. Let's take a look to see what other, maybe we can see what else you guys want to look at. Is there one other thing people would like to look at? Shall we very quickly do something with the lyrics? And some of it will be a little bit like me jumping ahead, but then we can do a bar plot based off of that. How about that? We'll do something with text analysis where I jump ahead a bit and use some functions I haven't taught you before, but then we do a bar plot of things. So I'm going to go ahead and go under the text analysis part. Let's start with Beyonce. Okay, so the data set was called Beyonce lyrics. So what we're going to do when you do text analysis, one of the things that you do is, instead of looking at the lines, we would look at, for example, we can look at words. So we need to take these lines and then we need to separate them into every single word in a line. And that tidy text package basically does that for you. So there's a function called unnest tokens. Whatever you do the text analysis on is usually referred to as a token. So in this case, we're going to work with words, but there are other ways of doing working with text data where you look at phrases or sentences. That the bigger they are, the more it gets complicated, because then you're trying to make the machine think more like a human than a machine. But the words, it's an easy thing for it to do. It just chops it up wherever it sees spaces. So the output, we're going to call it word, and the input, if I look at the say lyrics data, the name of the column where I can find the words was called line. So let's do this. So what we can see here is that, see, for each of the lines, so this is still line number 1, I have basically unnested it such that the words that appeared next to each other in a line are now are now in their individual rows. Okay. And then what we might do is we might say, okay, count for me the words. And then we can say sort through to find what are the most common words. You, I, the, me, to, it. I mean, it sounds like Beyonce has really boring songs based off of this, right? So what we call these are stop words. They're the words that appear in every sentence, but don't tend to carry a lot of meaning. So actually what we can do is we can say, just get those words out of there. So before we do the counting, we can say we're going to do an anti-join. So that's to subtract things out. And this package actually has a list of stop words as well. So people who work with text data actually use these repositories of words that are known to be true. And so there is a function called get stop words to get that. So now I actually see what Beyonce says a lot more. Okay, so things like, oh, like, love, go, baby. So how about we make maybe we do something like, we learned the slice max function recently, right? Could we say something like the top 20? Oh. Okay. So here are the top 20 words by Beyonce. And maybe we can make a bar plot of these. Okay. Here I can, so I am going to post this stuff afterwards. So you can get the code when I post it there as well. And I'm sorry, the university has disabled copying from Zoom chat. Like, I don't know why they decided this, but even if I paste it there, you couldn't copy it. Okay, so let's make a bar plot. The data set we're plotting is this. On the, on the y-axis, I'm going to put the word. And on the x-axis, I'm going to put the n. And then let's do here are words, but they are in alphabetical order as opposed to what's the highest number. So we can actually say we want to reorder these in order of the n. So maybe that looks a little bit better. Okay. So let me show you guys one other thing quickly. Now that we developed this code, the nice thing about it is I can literally copy and paste this down. And I can say, instead of Beyonce, give me T Swift. Oh, maybe I can't do that. Let's see. Was it not called T Swift lyrics? Yes. And so let's run this. Oh, look at this. The name of the column for that other data set is not line, but it's lyrics. So let's try to change that. And here is what it looks like for Taylor Swift. Maybe if we saw these next to each other, it would be a little bit easier to see what's happening. And to make our life a little easier, I'm going to do just 10 of these, okay? So let's add a title. This is Taylor Swift. And this is Beyonce. And I am going to very quickly teach you guys one other package called Patchwork, which allows us to put plots next to each other. And because we're running out of time, I'm going to write an explanation about like how I'm using it when I post these. But I just wanted you to be able to see these next to each other. Can you please not do that? I'm going to ask one more time. Please don't do that. Okay, here we go. They both say "oh" the most. Like that's basically what we figured out from this. And then like a lot. Then the third one for Beyonce is love. But the third one for Taylor Swift is no. So one of the things, I mean, in the last 5 minutes, I've used a bunch of functions I haven't talked to you about. So as we wrap up, I will tell you kind of what of these things we will learn soon. The things that were mostly about text analysis, we're going to have a module on text analysis at the very end of the semester. So you'll see more of that then. This sort of joining data frames is something we're going to learn about next week. And then ggplot is basically what you've been learning this week anyway. So here is what things look like kind of next to each other. If we had a bit more time, we could do things like, you know, tidy up the axis labels, maybe use a different theme or whatever. So the way I combined them is I named my plot something. So I just named them P1 and P2. And then I said just P1 plus P2, and it basically puts them next to each other, places them onto the same plot. And the name of that package was patchwork. It basically makes a patchwork of plots. All right. So what I'll do is I'll knit this whole document and post the code and the result if you want to take a look at it. In terms of what we've done that's like directly related to what you've learned this week, anything that starts with ggplot and onwards. And for tomorrow's lab, you're going to basically work with a data set where you don't need to do any sort of cleaning. You don't need to worry about, oh, was that a numeric variable or not? Were there additional characters I need to worry about? But instead you can, it's actually a data set I have pre-cleaned for you so that you can work with just the functions you were responsible for learning this week, which is just doing data visualization. Are there any last minute questions before we wrap things up? All right, if you want to get practice working with this, as I said, the project is available on our Studio Cloud, so you can keep working on it, and I'll post my code if you want to see what I've done and expand on that as well.